47.b is talking about the arctan. And a couple of things we have to remember about arctan before we can start this lesson. First of all, the arc means the angle whose tangent is, in this case. But there's some limitations on tangential lines here, or not tangential, arctan lines or angles, and that is it's going to have to be from -90 all the way up to 90 degrees. That's the range that it's allowed. So the arctan can only be from -90 to +90, and the capital A is what's telling us that. And that's a couple lessons back, but if you need to look back on that, that's fine. But that capital A is dictating that the arctan can only be from -90 to +90. So let's take a look at the first one they did here, sine of the arctan of 1/√3. The arctangent tells me it has to be between these two lines, which means this is like it's non-existent over here. So when I do so, I look at that and I say, where's this going to be though? This is opposite over adjacent, so opposite and adjacent, right? 1/√3. So I say, which angle is this? A 1√3. That leaves me with a 2 here, and that's my special triangle. We should be able to recognize that special triangle at this point. So when I realize it's a special triangle, I'm looking for the sine whose arctan is 1/√3. Well, the sine of 30 is opposite over hypotenuse, so 1/2, and I realize where this was at. Now, the book doesn't go into it, but there's another quadrant that I could get this to be both positive for this. That would be all students take calculus. If this wasn't a capital A here, there would be two possible answers. It could be in the first or the third quadrant. That would be confusing for us because it would give us a very similar answer, except that it would be in this quadrant would be a -30 right here, like this. And if I did so, I would have to say this could be a 210 as well. So the sine of 30 is 1/2, and I could use the sine of 210 as well. And that's going to make it really confusing. I can't come up with a single answer. So this A is telling me it has to be from here to here. Now, let's keep that in mind as we go into example 47.3. And it says the arctan of the tangent of 135. Now, at this point, I know what I would be thinking as a student, and that was, I know that the arcsine of the sine is like it wasn't there, right? The root of something squared, it's gone. And so I could just say, well, obviously it's 135, and that's my answer. But there's a little bit of a problem with that, and that is, this is a capital A. 135 degrees puts me into the second quadrant where the arctan can't exist. Because remember, the arctan has a range of -90 all the way to +90. It can't exist over there. So how's this going to work? Well, let's just take as if it said the tangent of 135. So we're just going to take just this, and I wrote it here. Let's say tangent of 135, and let's solve for that. Well, tangent is opposite over adjacent. 135 degrees puts it here. That's a 45-degree angle, which is really nice because then it's a 1/√2 triangle. And I've gone ahead and labeled that 1/√2, except that I've got a negative in here. So when I do so, I realize the tangent of 135 is going to be opposite over adjacent, 1/-1. Well, that reduces just -1. So the tangent of 135 is -1. I'm not quite done. I'm going to put that in here and say the arctan of -1. Well, keep in mind, there we go again with that big capital A up there telling me that it has a range of -90 to +90, but I realize that the negative tangent could be, the tangent is going to be negative in this quadrant, but there's another place it can be negative, and that's over here. So because I'm limited to only using these two quadrants, I have to draw it in the fourth quadrant. It's the only other place that the tangent is negative. So when I do so, I realize it is a down 1 and over 1. There's my 1/√2 triangle again, and that would give me a 45. Well, how could I label that? Giving the range of -90 to +90, and that would be at a -45 degrees. So the arctan with a capital A of the tangent of 135 is -45, because there are two places where that 45, 45, 90 triangle exists that would give me a negative value here and here. But this A limits me to this fourth quadrant, and so I have to use the fourth quadrant version. don't let this be too confusing for you. Just remember that I'm going to break these problems into two pieces and not let one piece affect the other. So I solved for the tangent of 135 first. I got that that was a -1, and then I plugged in that -1 into my original and said the arctan a -1, and then I started the problem over as if I didn't already know it was in the second quadrant, applying the limits of the range that I'm allowed to do, which is from -90 to +90 for the tangent, and that gives me the correct answer. So these are not difficult as long as you'll take the time to pay attention to the detail. The range, when I have a capital A, of the tangent is -90 to +90.